Hey, AJ.
One.
Everybody else decide not to come today, AJ? I feel like somebody should be here besides you and I. It's 9.
Let's get a bit more time.
Okay.
Thursday. It's practically a Friday.
Yeah, I agree. I'm feeling like I don't want to do anything.
I just want to sleep.
Yeah. Oh, there we go. Amanda's here. Thank goodness you guys are here. AJ and I started getting worried.
Yeah.
All right. I have a question for you guys before we start. I'm going to a meeting today and I'm supposed to bring an online game like, Among Us. You know how people play Among Us, but I'm not bringing Among Us, just so you know. So, does anyone have any other good game ideas that they've played online, like that would be appropriate for a school meeting? No one has any ideas. Nobody's doing any online playing.
I bring Tetris.
It's kind of hard for everybody to play though, right?
Oh, you all have to play it?
Yeah. So like, how Among Us, like 10 people can play at a time or whatever?
Oh, I have no idea. I don't have a lot of friends to play games with.
I apparently don't either, right? I was thinking maybe like a Pictionary one, because that's easy, right? Okay, nobody seems to care. So that's fine too. All right. So let's see what we have going on. Today is Thunderbird Thursday. I'll share a little bit more when more people arrive. But in the meantime, let's do a warm-up problem. AJ and I were talking about how it's Thursday, almost Friday. We just want a nap today. Anyone else there with us? Yeah. Okay. So here's a problem. It says 11 Olympic sprinters are eligible to compete in the 4x100 meter relay race for the USA Olympic team. How many 4-person relay teams can be selected from among the 11 athletes? So think about that and get it ready in the chat, but don't hit enter yet. All right, you're thinking about that warm-up problem? You can get your answer ready in the chat. All right, are you ready? 3, 2, 1, go. All right. Good job. So, what did you do to get your answer of 7,920? Anyone explain it to me?
You just took the 11 and went down by 1. So 11, 10. 11 times 10 times 9.
How did you know when to stop, Malachi?
It said how many 4-person relay teams, like, and it's a 4x1, so like there's 4 people in a 4x1.
Exactly. So you start after 4, right? Nice. And it matters where you run in a relay team, right? Like they care about who runs first, who runs second, who runs third, who runs fourth. They're very strategic in this. Yeah. All right. Good. So before we go too much further, let's talk about Thunderbird Thursday. There's a lot going on, and there's a lot of ways you can get distracted from your goals and just get depressed or have just other issues come up. So I wanted to go over, especially this time of the semester, there's some websites where you can get help. And then there's an article about happiness that I thought was interesting. And then there's also 3 positive psychology practices for during these troubled times. So I want to share that. And then I want to share one other thing with you. So I just put those in the chat so I can pull them up so you can see what things we have available to you. We talked about this at the very beginning of the semester, but you might not have seen it at that time. So here's some helpful resources for students, okay? So we have academic needs. Here's all these different things you can have for academic needs. But we also have, which I think might be even more important right now, is some basic needs, some personal well-being. So abusive relationships, childcare, financial crisis, if you need food assistance, which we've been talking about a lot, how do you pay for college resources, all those kind of things. So this is a great website to keep handy if you are in need or you know someone who's in need of these resources, okay? So MCC works really hard to have things available for the community as well as our students. This is a great article about what is happiness and how you can be happy, and those kind of things. So, and then some myths of happiness, which I thought was pretty interesting. So, especially regarding finances, a lot of you probably are of the mindset that if you had all the money you needed, you would be happy, right? A lot of people have that. Well, this is about a research study that says it's very interesting that not millionaires are the happiest. It's really people that have an income between 60 and 95,000. So it's a fascinating study for me. And any of you who are interested in psychology, this might be an interesting article for you. And then the last one, 3 positive psychology practices for our troubled times. We've talked about some of them, the 1, 2, 3s of gratitude, somehow getting that mindfulness Monday, things like that. Write a self-compassion letter. Have you ever noticed how nice you are to other people who are having problems? You're usually like super nice to them, but you're not very nice to yourself if you're having problems. So the idea here is be compassionate to yourself as well. Don't be so hard on yourself all the time, right? How you would treat another person is how you should treat yourself, right? I always thought that was very interesting. And then maybe take a walk. Now, we're going to get so hot that you're not going to want to take a walk at certain times of the day. But while you still can, you might want to get outside and do those things. Okay. The last thing I wanted to talk to you about is, hopefully I have it up here somewhere. Let me see. It's time for student government elections at MCC. And some of you are like, are you kidding me? We actually have a student government. We do. And I actually have the student body president in my other class, in my 1030 class. But now these are the positions that are open. The president, the executive vice president, the VP of communication, the VP of fiscal, and the VP of Red Mountain. The qualifications, you might think you don't meet them, but you probably do. You need to have a 2.5 GPA. That's not in high school. That's now, right, in college. You have to have completed 6 college credit hours when the term of office commences, which is fine because this class is 6 credit hours. So if you finish this class successfully, then you meet that criteria. You have to be enrolled in 6 credit hours in the fall and spring. So in the fall, you would have to take at least 6 credit hours. And then you have to commit to serve for 1 year. Leadership experience is great if you think of maybe something you've done at your church or at your school or in your job or something like that. And there's an online application as well as a packet. And these deadlines are, let me see if it takes me to this one. So here's the information. The application is due by April 23rd. Okay, so make sure, and then the election days are the 5th and 6th, and then they'll have the results by May 7th. So if you are interested in any leadership position or a leadership job in your future, ASMCC is a great experience. So I just want to make sure that you guys are aware of that, because some of you might be interested in government or how the community college runs, or you may be real passionate about something that's happening or not happening at MCC in regards to something you're interested in, whether it's clubs, diversity, inclusion, I don't know, whatever it is, but you could be the one to make the change on the campus. Okay. And we've had our past ASMCC presidents are really given the opportunity to talk to leadership at MCC. So they meet with our president and things like that, as well as other important people on campus. And they also get exposed to a lot of scholarship opportunities, job opportunities, transfer opportunities, and things like that. So if you have any interest in those positions, and remember there was a lot of them, so you might not want to be the president, but you might want to be a different type of leader, like if you're interested in the fiscal aspect of it or something like that. So I just want to put that out there because especially in this online time, I'm not sure that you're going to hear it from a lot of places. Okay. So take care of yourself. And if you want to make change in our community at MCC, please apply for ASMCC. Any questions? All right. Okay. We talked about the calculator a little bit the other day, but we didn't really use it. So today we're going to use it a little bit. And some of you will like the calculator. And some of you will be like, I don't really need the calculator, which is totally fine. It doesn't matter to me at all if you use it or you don't use it, but know that it's available to you. So I just put that calculator in the chat for you. I'm going to give you the worksheet for today. Okay. And we're going to talk about a little example. Let's talk about why we would want to use this formula instead of just using the basic counting rule. Well, as you can see, it says we won't actually use this formula very often. We only developed it so we could attach a special notation and a special definition when we're choosing our items out of n possibilities without replacement. So that's really important. Without replacement, so no repetition, and where order of selection is important, like we just talked about, right? So the order of the 4 runners in the 100-meter race, and if we're choosing first prize, second prize, third prize, or if we're choosing president, vice president, secretary, those kind of things. And we have this formula for permutations right here that says, and how we read this, by the way, is NPR, okay, or N choose R, but it's with permutations. So N factorial, did we talk about factorials yesterday at all? We will in just a second. So factorial means something very specific, and then we're going to divide by N minus R factorial, where N is the number of total items and R is the ones we are choosing. So if we think about our warm-up solution, first, let me find my factorial conversation. Where is it? Hold on. There we go. Let's talk about what factorial means first. So factorial is just a shortcut way to write, take that number and multiply it by that number times 1 less than that number until you get all the way to 1. So for example, if I have 6 factorial, that means go 6 times 5 times 4 times 3 times 2 times 1. It's just a shortcut way to write that. So if we look at that calculator, we could do this on our calculator, right? Or we could do it by hand. 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360, 360 times 2 is 720, right? So, and you could do it on your calculator just regular, like 6 times 5 times 4 times 3 times 2 times 1, and you would still get that 720. If you wanted to use this calculator, hopefully I have it somewhere. Why? All right. So if I just want to put in here 6 for n. Doesn't matter what r is right now. I'll just put 3 because we don't care. It's going to solve all this. So do you see n factorial? It's highlight. I mean, it's really grayed out. It just says 720. So it'll do n factorial. Don't worry about the other numbers yet. We'll do those in a second. Okay. So 6 factorial just means 6 times 5 times 4 times 3 times 2 times 1. 10 factorial is just 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so instead of having to write all that out, you could just write 10 factorial. So it's just a shortcut. And you need it in that formula. So now if we look at our relay that we had in the beginning, we could do this formula. 11P4, because we have 11 runners possible, right? There's 11 runners possible, so that's our N. And then we're choosing 4 of them. But we can only use this formula when we can't repeat anyone and when order matters. Now, notice we got the same answer. I don't know why I wrote it backwards. This was 7920. Okay. So we got the same answer as if we just multiplied 11 times 10 times 9 times 8 times, so yeah, 11 times 10 times 9 times 8. Now, I wrote out the formula so you could see what it's doing. You probably don't care because the calculator is going to do it for you. But in case you do care, do you see how I wrote 11 factorial over 11 minus 4 factorial? And then I know 11 minus 4 is 7. So I wrote 11 times 10 times 9 times 8 times 7 factorial, because that would be the rest. And then I have 7 factorial in the denominator. So those two simplify to 1. And I end up with what we had already written out, which Malachi explained so easily, right? 11 times 10 times 9 times 8. So do you see how you don't have to use this formula? We did all the problems yesterday without the formula. I can really only think of one circumstance where we have to use the formula. And that's on your worksheet, on your formula sheet, and we'll talk about that in a minute. So if you're using a graphing calculator like this, you have this button too. If you hit, so to do this one, if you have a graphing calculator, let's say we want to do that 11, choose 4. You type 11 first. Then you hit the math button. And then you arrow over to where it says PRB. Do you see that menu? PRB. It's the last one on the right. And then a menu will come up that says RAND, and then it says NPR, NCR, and then a factorial. Go down to number 2, that should be NPR, and hit enter. And so now your screen should say 11 NPR, and now you hit a 4 and hit enter, and it should say that same number, 7,920. Yeah. So I knew Valerie had one. Anyone else have a graphing calculator that they want to see where that button is? Did you find it, Deshay?
Yeah, I found it.
Good. And you'll see that the combination formula is right in that same menu. And we don't need that one until we do PC7. But in case you're working ahead, you might want that. And notice that on our app that we made for you guys, if you don't have the calculator, it'll calculate both NPR and NCR. So if we go back to that, and I put in that 11 and 4, and I hit solve, it tells me what n factorial is, what NPR is, and what NCR is. Now, you don't know what NCR means yet, but you will next week. Let's see if it's on Desmos. Let's take a look and see if it's on Desmos. I didn't look for it on Desmos, but it's probably there. Yep, it's right there. Did you see where I was? When you go into Desmos, it first just says main, but you could go to function and you could hit this. And so this one is a little bit different. So I bet we have to put an 11 and then a comma 4. Let's try that. There we go. So on your graphing calculator, you have to put in N first, then choose NPR, and then put in R. On Desmos, you just have to go to the functions menu to find that NPR. I'll clear it and do it again. So we're on this main menu. You hit functions, you hit NPR, then you have to go back to the numbers and you go 11, comma 4, and then you end your parentheses. There you go. Good question, Jen Day. Yes, you can still use Desmos. And I'll make sure that's linked in our quiz still for next week. It should be. I don't know why I wouldn't link it. All right. So I know that formula might seem confusing. I really don't use those formulas hardly ever. I might use them to check my answer, but for me, it's harder to remember which formula it is to use than it is to just think through the problem. Okay, because it's very easy to get tricked and go, oh, this is a combination. And so you just do the formula real quick with your calculator and you write it down, but you haven't really thought about the problem and you're actually wrong. So be careful. Okay. This is the first problem on your worksheet that I gave you. How many different ways can the letters of the word math be arranged to form a 4-letter code? And I'm not going to say word because it's not really a word. Okay. So it says this problem is a bit different. Instead of choosing one item from each of the several different categories, we are repeatedly choosing items from the same category. And the category is these M, A, T, and H. So we've done a problem like this already. So you have 4 choices for the first letter. Then you only have 3 choices for the second letter, 2 choices for the third letter, and 1 choice for the last letter. And then notice this is what's different from today. For today is you could do 4P4, right? Because I have 4 things total, M, A, T, and H, and I'm choosing all 4 of them. So it's 4 times 3 times 2 times 1, which is 24. Same stuff we talked about yesterday. Okay. Any questions on that one? Okay. Let's try to think through these. So 4-letter words are formed by using the letters A, B, C, D, E, F, G. How many such words are possible for each of the following conditions? Well, the first one, part A, they said we're not making any rules. So you can do whatever you want with these. And there's 1, 2, 3, 4, 5, 6, 7. So I'm trying to make 4-letter words. So I'm just going to put 4 lines right here because that helps me make sense of it. So how many choices do I have for the first slot here? 7. Very nice, Valerie. Now, if it says there's no rules, no condition is imposed, how many choices do I have for the second slot? Still 7. And the third slot? Still 7. And the last spot? Still 7. Now notice you cannot, I repeat, you cannot use the permutation formula for that because permutations don't allow repeats. Okay, so you just have to do 7 times 7 times 7 times 7 or 7 to the 4th power. Okay. And so for an answer, did you get 2,401? Excellent. So see if you can do part B, C, D, and E. And you can send me your answers one at a time. Just don't send them to the whole class. Okay. And I'll give you guys about, I don't know, 5 minutes. and you let me know if you have any questions. All right, so I was just giving you guys some time. It looks like I have 2 students that completed it correctly. I have some students who sent me nothing. So I don't know what's happening there, right? All right, so here's what I'm noticing. Some of you are doing great, and I'm suspecting it's because you're doing everything you're supposed to. You're doing your mini lesson, you're doing your textbook reading, you're trying questions, things like that. Some of you literally, I think, aren't doing anything. Like you might have been absent. You definitely didn't watch the recording. You're probably not doing your mini lesson. You're definitely not reading. And so you don't know what you're supposed to do. Some of you are doing okay. So I can tell you're doing some of your work and you're understanding some of it, but some of the wording is a little tricky on some of these, right? So you get stuck on some of the harder ones, and that's totally fine. That's normal. So if you're getting stuck on some of the harder ones, that's good. But if you have no idea what's happening, there's a problem. Okay, because we have one more section and then you have a quiz. So what that means is I should have seen you in office hours last night. Didn't see any of you there. I saw one student from my 10:30 class who was already working on her video for the review. Nice. She wanted to verify it was the correct answer. So that was good. And besides that, I don't see anyone in my office hours in the morning or on Wednesday nights. So the bottom line is it's really up to you, right? How are you going to finish this semester out? Are you going to end up passing, or are you going to make it so you're not successful? So be real careful, because you're at a turning point right here. Okay, this is not easy material. I know it's not. So let's take a look at this. And I know a lot of you got some of them correct and some of them wrong. So part B says no letter can be repeated. So I can't repeat anything. So the first, I'm still picking 4 letters, right? For all of these, I'm picking 4. So if no letters can be repeated, how many choices do I have for the first slot? Jen, go ahead. Deshay, go ahead.
You're gonna choose. Oh yeah, 7. Sorry.
Yeah, you're good. Did anybody use the formula on this one?
Yeah, I did. That's
There
why I
you
was
go.
confused.
There you go. I bet. Okay, so what formula did you use, Deshay? What did you put in your calculator?
I did 7, and then the P, and then 4.
Perfect. 7P4. Perfect. However you did it, whether you did Desmos or, the little app or your own calculator, it doesn't matter. So, but since I can't repeat, my first number is 7. Then I have to go down by 1 times 6, then times 5, then times 4. Either way you do it, you'll get the same answer. And your answer would be 840. Everybody okay? All right. Now, these next ones are where it gets a little bit trickier, right? On C, D, and E get a little bit trickier. So let's look at C. It says each one has to start with the letter A. So I still have 4 little slots here. But this time, this first one, I don't have very many choices. How many choices do I have? If it has to be an A. One choice. That's it. Only one choice. So that's going to be a 1. Now, did it say anything like I can't repeat? Did it have any rules like that on here? Nope. Didn't tell me I couldn't repeat. So if it doesn't tell me, I assume I can. Okay. So I'm going to say I have 7 choices for here because it didn't say I couldn't put another A there, right? And then 7 choices for the next one and 7 choices for the last one. So if I multiply all those together, I get 343. Questions on that one? Does that make sense?
Why is it like only one on the first? So my thinking was like every single word had to start with A.
Right. So how many choices do you have for that first letter?
1.
Yep. That's why it's a 1.
So why like the other 7s? Because like in my head I was thinking like you have to make 4 words, but all 4 of them have to start with A. Or am I?
No, read the original problem. We're making 4-letter words. So here's our 4 letters.
Oh,
And we're choosing
okay.
from all of these.
I read the problem wrong.
There you go. And that's probably 90% of the issue with most of these problems is we read it incorrectly. Okay. Any other clarification I can do on that? Amari, Jendai, anyone? Ashley? Now's your chance to ask those questions if you don't understand.
I have a question.
Yeah.
For letter B, I
Yeah.
put it into Desmos wrong because it came up with a crazy number. So could you show us how to do it in Desmos? again?
Sure. So in Desmos, you have to pick, can you see my screen still? Yeah. Okay, so you have to pick function, and then you have to pick NPR, and then you have to go back to the numbers. And this time we had 7 that we were choosing from, and you have to put a comma in there, and then you have to put a 4 in there.
I think I forgot to clear it.
Yeah, probably. So that's why you have to be careful if you're just using the formulas, because sometimes there's something left in there that you didn't get rid of. So be careful. That's why I stray away from the formulas. And I know Aaron said he was just doing the problems and then checking it with the formula if the formula applied, which is probably a good strategy because the formula doesn't always apply, right? Out of these problems that we just did, it only applied to one of them, part B. Otherwise, you had to think about them and write these little slots down. All right. So someone who really is confused should help me do the next one. So it says the letter C must be at the end. So someone who's really confused, it would be a great time for you to go, okay, I'll put myself out there and we'll walk through it and hopefully I'm going to pass this class.
I'll go. I'm not like super confused, but a little bit.
Oh, good. And Jenday said she would go too. So either way.
Okay, I guess I'll go.
Okay. So what's the first thing you would do?
Um, uh, I guess you could put the lines. I mean,
That's exactly what I would do. I always put the lines because it helps me make sense of it.
um, and then it says the letter C must be at the end. So, um, it could be repeating.
Very
Like
nice.
it doesn't say it can't be repeating. So for the first one, I would put 7. Second one, I'd put 7. Third, 7, and then I'd put a 1.
Perfect. Excellent, Malachi. So that one was a little tricky because you were like, wait, that sounds a lot like part C. Does it matter if they put the criteria at the beginning or at the end? It didn't, right? So it didn't matter. Even if they said the second letter had to be a whatever, right? So it's you get the same answer as part C. Everybody okay with that? Good job, Malachi. Okay. So Jenday, the only thing on yours is the one would be at the end if you were trying to describe what was happening with each one, because it says the C has to be at the end. Does that make sense? You will get the same answer, but if you're trying to explain it, right? So it would be 7 times 7 times 7 times 1. All right, Jenday, are you brave and you're going to try the last one? I'll help you. All right. So what's the first thing I should do, Jenday, on this last one?
Well, put the lines first.
There you go. So let's put the lines. Then what?
Well, there's more than one vowel, but it has to be the second letter.
Yeah, so how many vowels are there?
There's 5.
Nope, in my list right here.
Oh, there's 2.
There's 2, and that has to be the second letter. So I only have 2 choices for the second letter. So I'm going to put a 2 on this line.
Okay, so
Okay.
would the rest be 7?
Why? Tell me why.
Because you have 7 choices?
Yep, because it doesn't say I can't repeat them. So I could have any letter I want for there. So, and if we do that math, 7 times 2 times 7 times 7, we get 686. So does that clear those up for those of you that were stuck on those? Yeah, they were a little tricky. So, and if you're going to take any of these to the tutoring center, or you're working on more, or you're going to come and see me, you need to come prepared, like with what the question is and then how you've tried it, because that's going to help the tutor understand how much you know and how much you don't know. Okay. All right. Now, these are a little bit trickier, and this is a formula on your formula sheet. And do you see how it says, in how many distinct ways can the digits in the number, what is that? 1,024,873,849 be arranged? And it says, if there are any 0 digits, then assume they can be placed in any position. So listen to this new formula. It says the number of permutations of n items where p items are identical, q items are identical, and r items are identical. You have to do this extra little step. And what do they mean by identical? They mean by that there's more than one of them. So if I look at these digits, do any of those repeat? And if so, which ones?
4 and 8, I think.
All right. So there's 2 8s and then there's 2 4s. And do you see how that would mess us up if we didn't count them? Because we would be saying that if I put a 4 in the beginning and then I put a different 4 in the beginning, that it's a different number, but it's not going to be. So this is the only time you have to use this formula. So now if I'm going to use this formula, I have to say, okay, how many digits are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 digits total. Now, what I have to divide by, because that would be normal, right? That would be if I just said, okay, there's 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many ways can I put a number here, 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 right? Without repeating, right? Because it says distinct ways. Okay. So normally it would just be 10 factorial, but since I have these duplicates, I have to divide by 2 factorial, 2 factorial, because I have 2 4s and I have 2 8s. If the 8 repeated 3 times, I would have to divide by 3 factorial. Okay, so to do this, you might have a little bit of trouble because you don't necessarily know what 2 factorial is. Well, this is 2 times 1 times 2 times 1. So what's my denominator really? What's 2 times 1 times 2 times 1?
Four.
Yeah. So you can use whatever calculator you want to do 10 factorial and then divide it by 4. Okay, so I'll just use Desmos because I think it's pretty easy. And I'll go over here to where my factorial button is. Oh, but I don't need it yet. I'm going to do 10 factorial. And then I'm going to go back here and I'm just going to divide by 4. And I get my answer. Now, I could, if I really wanted to, go divided by 2 factorial times 2 factorial. I'll still get the same answer, right? But Desmos allows you to put all that in there. So normally we would have gotten 10 factorial, but since we have these duplicates, we have to eliminate those duplicates. And these are very unique problems. You'll probably only see like 1 or 2 of these on more. So we get an answer of 907,200. So that one's a little trickier. All right. I have an explanation of this here too. So if you need to look at it later. Read through this example. I think the first question, part A, is very doable for you guys right now. So try part A. It says 6 similar cars are entered in a race. The cars all have an equal chance of winning and there are no ties. Spectators are invited to complete a single prize ticket with their guesses for which cars will finish first, second, and third. The spectator who guesses correctly will get a small prize. So how many ways can the prize ticket be completed? First answer that, and then we'll talk about part B and part C. So think about that for about a minute. So there's 6 cars, and you're trying to see how many different ways you can choose first, second, and third. All right, you're going to put that answer in the chat just to part A. Just to part A. Okay. 3, 2, 1, go. Very nice. All right, so that seemed like a normal question, right? That one seemed like, okay, I understand this. I could just do 6 times 5 times 4, which would give me 120. Or I could have used that formula, 6p3, and I would still get 120 ways. Now, so the reason now that I spent 2 days on this section is because now the questions are going to get a little bit harder because it's going to relate back to probability. So if there are 120 different ways the prize ticket can be completed, what's the probability that a spectator will win the small prize? Anyone remember how we would say the probability? Any ideas there on what you'd put? Remember, probability was successes or favorable outcomes to total outcomes. So how many ways can you pick it correctly?
Would it be 1?
Yeah, there's one way it's correct. And then how many total ways are there?
120.
Very nice. So the probability that a spectator is going to win is 1 out of 120. Does that make sense? Okay, so do you see how it kind of taught you the new thing of how to find how many outcomes? But then you had to go back and remember that when it's probability, it's written as a fraction, where your numerator is how many successes, right, there are. And we're not in odds right now. We're just in probability. Okay, now here's an interesting part. So spectators can complete up to 9 different prize tickets. So now what is the probability that a spectator with 9 prize tickets is going to win the small prize? So on each ticket, the probability is 1 out of 120. So how much does that increase their odds or their probability? Sorry, I shouldn't have said odds. What do you guys think? What would you do? So that's the first ticket, right? This is the second ticket. The third ticket, it's a 1. The fourth ticket, the fifth ticket, the sixth ticket, the seventh ticket, the 8th ticket, and the 9th ticket. What are we going to do with all these probabilities? Any ideas?
Would you just add them?
Yes, Olivia, that's absolutely correct. You're just going to add them up. And you might even think about it like this. You might go, okay, well, if I have 9 tickets and each ticket has a 1 in 120 probability, if I have 9 of those tickets, I've just multiplied it by 9, right? So 9 times 1 over 120 would still give you this same answer of 9 over 120. And you could simplify that to 3 over 40. So if you did 9 times 1 over 120, you would get this same thing. So either way, good job, Olivia. Okay. Okay. Now, I want you to read through this problem just to make sense of it, because it's talking about a housing development. So just read through this. I'll give you a couple minutes, and then we'll talk about making sense of it and how to answer some questions. All right. So what on earth is this problem asking us to do? Or what are we trying to figure out?
How many options?
Okay, we need to know how many options there are because we need to find a probability, right?
Yes.
Okay, so how many total options are there, or how would you figure that out? Whoops. Because you're going to pick one from each thing. So for example, you get to choose, do you want 2 bedrooms, 3 bedrooms, or 4 bedrooms? Do you want 1 bathroom, 2 bathrooms, or 3 bathrooms? Do you want 1 floor or 2 floors? And do you want desert or grass landscaping? So I want you to think about just what we were doing before. So we're choosing the number of bedrooms, the number of bathrooms, the number of floors, and the type of yard. Yeah? So we have 4 slots there. So Amari, how many choices do we have when we're picking the number of bedrooms? Amari, can you hear me? Amari, how many choices do you have when we're picking the number of bedrooms? Okay, so look at the problem. Do you see where it says number of bedrooms? Amari, I'm still talking to you. Do you see where it says the number of bedrooms?
Yes, I see.
Okay. How many choices are there?
1 bedrooms, 2, 3, 3.
There's 3 choices there. Very nice. Now, how many choices are there for the number of bathrooms?
3,
3. How about number of floors?
2,
And then how about type of yard?
2.
Very nice. Everybody with Amari on that one? Excellent. So if we multiply all those together, 3 times 3 times 2 times 2, AJ, what do we get?
$36.
Very nice. Did everybody get 36? Excellent. Now, here's the actual question. There's only one house left to buy. So what's the probability it has exactly what I'm looking for? 2 bedrooms, 3 bathrooms, 2 floors, and grass or desert landscaping. What do you think?
1 out of 36.
Do you think it's 1 out of 36? Anyone agree with Aaron? Oh, lots of people agree with Aaron. Okay, so 1 out of 36. I'm going to say I disagree. Ashton is like, wait, I just gave applause. Okay, and this is why I disagree, Aaron, because, and everybody who agreed with Aaron, I agree that there's only one that has 2 bedrooms, 3 bathrooms, 2 floors. But do you see how it could have either type of landscaping? I don't care if it has grass or it has desert. So there would be 1 out of 36 that has grass and 1 out of 36 that has desert. So it would actually be 2 out of 36. Tricky? Is that tricky? Because I only have 1 out of the 3, 1 out of the 3, 1 out of the 2, but then this last one is really 2 out of the 2. So it's 2 over 36. I know, it's annoying. That little tiny thing makes a difference. Okay, read this last problem. Okay, this can be a tricky one. So what's happening in this problem? Just tell me in words, what's happening? Nobody knows.
You need to figure out the probability of if Erica arrives first and Rocky arrives last.
Yeah, it's Rocio.
Rocio,
So
sorry.
Rocio arrives last. That's okay. No worries. So how many people are there total? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 people. Yeah? Okay, so we have 8 people. So why don't we just think about how many different ways they can arrive? How about that? How many ways could they arrive at the party? In general, not counting somebody arriving first and somebody arriving last. Because when we're doing probability, we need our total possible outcomes for our denominator. So Yesenia, what would we do in here?
Is there 8 different ways that they could arrive?
Well, remember there's 8 choose 8, right? Or 8P8, because we could have 8, 7, 6, 5, 4, 3, 2, 1, right? Because we have 8 choices for who arrives first, 7 choices for who arrives second, right? Does that make sense? So just a true permutation. Okay, so this is how many total choices. Now, then they put this little extra thing on there and they said, find the probability, so we know it's going to be a fraction, that Erica arrives first and Rocio arrives last. Do you see how that changes our problem? Because now I have Erica here. I don't know who's here. And then I have Rocio down here. Yeah. So what numbers would go in here? Because these are the ways I can arrange everyone else, right? Not including Erica or Rocio. So how many choices, how many people could I put here? I mean, how many choices do I have for who arrives second?
I don't know if this is right, but could you just put it down as 7 through 2?
Would
Since
it,
Erica counts as the 8th person.
okay, so, but remember, we got this person's gone and this person's gone. So how many people do I have to choose from now? Is it 7?
Well, you have 6 people, but
So I only have 6 people to
yeah.
choose from. And then 5, 4, 3, 2, 1. Do you agree? Nice. So do that math. So 6 factorial, right? Because that's what that is. Over 8 factorial, because that's what that is. So I'd really have, do that math, see if you can get a simplified fraction. And you can do it all on the calculator, right? Day, that's not what I got. Did you do 6 factorial over 8 factorial? Did you get 1 over 56? Yeah? Excellent. Okay, so, but do you see how that one was much more complicated? We had to do a lot more thinking on that one. So, because you originally got 720 over 40,320, which is 1 over 56. And I have all my work here too. Now, some of you turned in your worksheet already, but not everyone did. So make sure you know that you have PC6 worksheet due tonight, right? It needs to be in a PDF and submitted on Canvas. There's an assignment link. Otherwise, here's all the other stuff you should be working on. You should be working on PC6 more practice, which is due tomorrow night. Then you have PC7 mini lesson, PC7 reading quiz, your those two are due Sunday night. You also have your PC7 homework that's due by, I think, Tuesday night. And you have your review video that's due by Tuesday night. Okay, because then we're going to review on Wednesday. I think it's due Tuesday night. And then your review is on Wednesday, and then your quiz is Thursday or Friday. Okay. All right. So I put your exit ticket up. Go ahead and try that. And let me know if you have any questions.